Okay, hi guys, and welcome to part 3 of the motorised bicycle kit build. And as mentioned previously, I'm going to do a separate one entirely on the carburettor because I want to sort of cover principles of the carburettor for anybody who is unfamiliar with how they work, and hopefully this will help you with any kind of running setup and running problems. So we start off. What we have is the throttle twist grip, which twists a cable inside here. Inside here is a sleeve which slides over your existing bar, and that rotates on that. Inside there the cable runs down through here, along here, and to the carburettor itself. Just before we get to that, on the throttle twist grip you have an engine kill switch, which is normally where you'd find your starter on a motorbike, an electric powered motorbike, motorbike with a starter rather. And you have the wiring there, 2 wires. It's basically one of them goes to earth, one of them goes to your engine, and what's happening is you're shorting it out to earth and you're killing the spark. So when you press that, it just kills the engine. And you've got 2 adjustments, one on either end with a locking nut. You can adjust the cable out and make it tauter, or you can make it looser as appropriate. And then we go down to the carburetor unit itself. Now if you look in there, try and do this and twist the throttle. You see that there? And what you're seeing there is the slide, which is directly actuated by the cable moving up the bore, opening the venturi of the carb. This is this bore that runs through this way, or runs through that way to be precise, because the air is coming through here into the cylinder. And under the piston you have a tapered needle, the thin line. Also have a choke, which is a simple fuel enrichment device. Now if I can flick that on, there you go. It's basically a washer, a glorified washer. It narrows the port, minimises the air and maximises the fuel to make a richer mixture for starting. So a simple flick up and flick down operation. Unfasten this top cap here, and what this will do is lift out the entire slide assembly. Now when you remove these you have to be careful. Make sure you don't bend these needles, they're made of quite a soft material, and if you bend that it will mess up the whole thing. Just have a look at that. What you have is the screw-on cap, or a spring which basically returns the piston back down the bore. The piston itself will have a slot on one side which locates with a pin inside of the bore, you can see there, and on the other side there will be a stepped portion, and that stepped portion allows you to turn this screw at the side, which turns a screw down inside there, acting on that, and raises or lowers this piston to adjust your idle speed. Now bear in mind this doesn't affect your mixture whatsoever, this just adjusts your idle speed. So the higher up the piston is up the bore, the faster the idle speed, the lower down the slower the idle speed, and you're aiming for an optimum where it's not using too much fuel and revving like crazy, and obviously it's not stalling. And then the needle itself, as I say, that fits down through the piston there. There's your air filter, simple affair with a foam filter rather than an actual air box. So your fuel comes in here, flows down into your float bowl, and it will raise to a specific height. The float then lifts up inside, presses onto a needle valve and pushes that closed to stop your fuel flowing through. Once fuel is used, sucked up through your jets, through there and out into your chamber, the level drops, the float drops, and the needle valve opens again, more fuel flows through, and the process happens all over again. As I say, that's your idle adjustment there. This little button here, you see there, now that's something you don't see very often on carburetors. You'll find these on old classic machines, and the old boys tend to refer to them as a tickle button. And basically what that does, in this particular case, it pushes down the float, allowing the needle valve to open and more fuel to flow through. and it works in a similar fashion on most of the old carburetors. This is kind of like an additional enrichment device, because if your fuel level in your float bowl is too high, it will actually suck up more fuel through your jets on initial starting and give you an overly rich mixture. This is why the height of the fuel in here is so critical. Now what this does is when you're on a first start or a cold start, you give that a few pumps until you see fuel starting to seep up through there, which means your float bowl's completely full, and that will give you a bit of an extra rich start boost. There we go. Now that's the float bowl off. I'm just going to look at the float bowl first and foremost. Now inside there is the float, kind of like a plastic donut. That's your float bowl. Simple as that. That little pin that you can see there is your tickle button, and that's the one that pushes down the float. Now there, I'll show you this way up. You can see that there? That's the bit that the float pushes up against. Underneath there, as I say, it'll be a wee bit tricky to see, but there is a valve that pushes up. Now that will have a conical end, and that effectively seals off the flow of petrol, and as you can see, it's directly below the inlet for the fuel there. That pushes up and it will stop the flow through of fuel once it's reached its limit there. And if you need to adjust the height of this, to adjust the height of fuel in the bowl, you would effectively bend these tangs here, whereas on one where it's fixed to the float you'd have a little separate tang up here. But, this is your main jet. Usually these have a hex head and a screw slot as well, but in this case just a hex head. You can unscrew that and change that, and if you could find a supplier, you could actually change the jet to different sizes, and theoretically you can get different taper needles for tuning the thing. Okay, that's the whole thing back together. I'm just going to run through how that would actually work. Once your slide's inside there, what happens is, as your piston moves up and down, it will suck air through the carburetor, which comes through the filter at the back here, sucks it straight through this tube at the front, which is called the venturi, and as the air passes over the pilot jet there, it will actually suck fuel up from the float bowl, which then becomes atomized, makes an air-fuel mixture which goes into your combustion chamber. On a 4-stroke it would go down through your inlet valve. On a 2-stroke it goes into the actual chamber, which cycles around the engine and then gets drawn up and over and into the crown for the compression stroke. What happens then is, as your airflow increases, the more fuel gets sucked out. So as your piston raises, your needle raises and the taper gets thinner, making the available space for fuel to draw up larger. The airflow passing over there will draw out more fuel. Now the thinner the needle, the more fuel it will draw out, and obviously if it's and the larger the main jet, of course. If it draws too much fuel through, it will run rich. If it draws too little fuel through, it will run lean, so it'll be set to run on an optimal fuel air level. And the air filter bin is a mesh cover, fine mesh cover with a foam filter underneath, which means that can be cleaned. What you would do is take that out, give it a clean every once in a while, and spray it with some light oil. Something like WD-40 would be fine, but you can get specific light oils for air filter oils in aerosol cans.